So everybody does have a no cheating calculators, yes? And it'd be good to have the calculators just to be able to follow along so that you are good there. So what we're looking at today is completing the square. So this completing the square is the first method that we're going to cover that actually works for all quadratic equations. Because up to this point, graphing works as long as it crosses the x-axis and we have some nice numbers, because integer numbers. If we have irrational numbers, it does not work as well. If the answers are the square root of 2 and negative square root of 2, we're not going to find good answers. It's not going to work well with graphing. Factoring, kind of a similar thing. If the answers are irrational or complex, they're imaginary, that does not work well with factoring. Square root method worked well as long as we had x squared as the only variable, or the only variable showed up in a set of parentheses being squared, because if we had those cases, it worked well. Now, completing the square works for all, and this is the first one, or first method that we will have for solving quadratic equations that will work for any and all quadratic equations. Now, there are several main steps for completing the square. Now, the first step, and the first thing that we're going to have is A equal to 1. Is A equal to 1? Is A 1? If not, make it so. Yes. Is A equal to 1? If not, make it so. Step 2 is to get the variables on one side and the constant terms on the other. So step 1 is A equal to 1. If not, make it so. Step 2 is to get the variables on one side and the constant terms on the other. Leave two spaces. And really these first two steps are to get us set up, to get us started. Step 3 is to find C, which is equal to B over 2 squared. Plug it in, or we can say add it to both sides. So C is going to go in those two spaces. We're going to plug it into both sides. Find C, which is equal to B over 2 squared. Add it to both sides. And the last step is to factor and solve. We want to factor that perfect square trinomial that we made it from finding C, and then solve using the square root method. So really these four here, these four main steps are how we're going to solve using completing the square. Now we're going to solve this here using completing the square. And once we see the steps and we see how this works, it's going to follow this method every single time. So we're going to do this here. Now the problem that we're going to start off with, x squared minus 16x plus 64, we've already done this problem before. We did this problem yesterday. And when we did it yesterday, we just started off with the equation and factored the left-hand side. We just went on and factored x squared minus 16x plus 64 and went from there. We're going to do the same thing, but we're going to apply these steps to it. And when we do this, it's going to show, and the reason we're doing this, I want to show that no matter what the setup, even though the left-hand side is already a perfect square trinomial, we can rewrite it as a set of parentheses being squared. This method still works. Because our first step, the first thing we look at with this equation, x squared minus 16x plus 64 equals 100. First thing we're looking at, is a equal to 1? And our a is always going to be the term in front of x squared. Ax squared plus bx plus c. Now we do need to make sure that all the terms, the variables, are together. We don't have x squared on both sides. We don't have that issue there. We do need, for the most part, we can get it equal to 0. Constant terms aren't a big deal. But the number in front of x squared is what? 1. 1. Because if there's not a number there, it's understood to be 1. If it's 0, we just don't write it. So a is 1. We don't have to do anything with that. Our second step is to get the variables on one side and everything else on the other. So the only thing that we have to move is the 64, because we need the x squared and x on one side, our constant terms or numbers on the other. So the first thing we're going to do here is subtract 64, because we want the two variables, our x squared and x, on one side, on the left-hand side. 100 minus 64, that'll be 36. And we're going to leave 2 spaces. We're going to put 2 spaces where we can plug that value of c back in to make it a perfect square trinomial so that we can solve by the square root method. Questions on what we've done so far? Now at this point here, we need to find the value of c. C is equal to b over 2 squared. And what is our value of b? It would be negative 16, because b is this middle term. So it's told to us in this here, we can see that b is negative 16. And we're going to replace b with negative 16. Now at this point here, we could put parentheses negative 16 over 2, close parentheses squared, and find out what that is. But it is nice to find the middle step, because negative 16 divided by 2 is going to be negative 8. Negative 8 squared, negative 8 times negative 8 is 64. So for this here, because it was already a perfect square trinomial, it just gave us back what we started with. And again, I'm showing this because if we did not know, if we did not look at it and see that, okay, x squared minus 16x plus 64 is a perfect square trinomial, we can still move the 64, find the value of c that is 64. And it's okay, it is telling us it's a perfect square trinomial. But on the plus side, when we go to factor this, our single set of parentheses squared with x, we can jump straight to it. We don't have to do our 2 sets of parentheses now with 3 spaces and factor it down. Because we know that the number in sign that goes inside this parentheses is the number in sign before we've squared it to find c. And what was that number? Negative 8. So it tells us that x squared minus 16x plus 64 is going to factor to x minus 8 squared. Questions on how we got to this point here and how we got this factored. We're good with this here so far. On the right-hand side, we have 64 plus 36, which is 100. Now, the last step we have is factor and solve. We've done the factor part. Now we just need to solve. First step in solving is going to be square root of both sides. Now we're just doing the square root method. On the left-hand side, our square root and square will cancel, telling us x minus 8 is equal to plus or minus. Whenever we take the square root of both sides, we have to put the plus or minus. Now we do need to take the square root of 100. So we can pull up either calculator, say square root of 100. It'll tell us it's 10. The graphing calculator and the 30xs, the yellow calculator, both of them will tell us it's 10 because 100 is a perfect square. It simplifies the radical completely. Now we can say we're done as long as we have x by itself. Is x by itself? No. So what do we need to do to get x by itself? We add 8 to both sides because negative 8 plus 8 simplifies, leaving us with just x. And that number we add or subtract, we've got to put it in front of the plus or minus. So it's telling us that our solution so far is x is equal to 8 plus or minus 10. Now that is the final answer as long as we cannot add and subtract 8 and 10. Can we do 8 plus 10? Yes. So we will have to simplify it because 8 plus 10 is 18. We can also do 8 minus 10, which is negative 2. So this one here does work out nicely. We get two nice answers, negative 2 and 18. We have the two values of x that will make this function be true, this equation be true. Questions on the steps we used here? I want to skip that one because that's another one that does work out nicely. It's already a perfect square trinomial. I want to look at this one here. X squared minus 4x plus 8. X squared minus 4x plus 8. Now it does have everything on the left-hand side, and that's fine. But our first main question, because again, we don't have x squareds on both sides, we don't have 4x's. All of our terms are on the same side, which is preferred starting point. Is a equal to 1? Is the number in front of x squared 1? Yes, because if it's not, we need to make it so. We need to make it be 1. So if it's not, we would have a number in front. Because it'd be 2x squared, 3x squared, and we would have to do, yes? Yes. We would have to divide by that number to make it be 1. Because we need that number in front of x squared to be 1. So we're good with step 1. A is 1. Step 2, get the variables on one side, constant terms on the other, and leave 2 spaces. We need that spot to put c back in. So for this here, what do we need to do? We need to subtract 8 from both sides because the left-hand side, we are going to be left with x squared. We still have negative 4x plus blank. 0 minus 8 is going to be negative 8. So again, we leave that space on both sides. So we subtracted 8 from both sides. We're good with that there. Now the plus, and we leave those 2 spots. Now the reason we're adding that plus and we're leaving those 2 spots is to put that value of c back in, so that we do have that perfect square trinomial to be able to factor and take the square root of both sides. So questions on steps 1 or 2. Step 3 is to find the value of c. We need to find this value so that we can make the right-hand side, this x squared minus 4x, be a perfect square trinomial that we can factor and solve. Now for this problem here, the value of b is what? Yes, it would be negative 4. And we can plug that into our formula for c. c is equal to b over 2 squared. So for us here, it would be negative 4 over 2 squared. Now again, we could plug it all in, but we would lose the number that we need when factoring. Now negative 4 divided by 2 is negative 2. Negative 2 squared, negative 2 times negative 2 is positive 4. So we can plug 4 into both spots. Now it's interesting that it is 4. It's more just this is how it works with this problem here than it is that it has to be 4. Questions on this here? Questions on anything we've done before we start factoring and solving? So we set this up to be able to factor the left-hand side into a single set of parentheses being squared. Because we'll have a set of parentheses in x. Now what's the number and sign? Negative 2, because the number inside the parentheses before we squared it to find c is negative 2. So x squared minus 4x plus 4 factors x minus 2 squared. Negative 8 plus 4 is negative 4. So we finished half of step 4. The other half is to solve. So our next step in solving is to square root both sides. And on the left-hand side, the square root and square will cancel. Like I said, we have x minus 2 is equal to plus or minus. Whenever we take the square root of both sides, we've got to put the plus or minus. Now we have to take the square root of negative 4. So we can grab a calculator, second square root negative 4. Domain error. So we can try the graphing calculator if we want. 2i. If we do this by hand, we know the negative inside a radical has to come out as I, because that's just our square root of negative 1. It's making it possible for us to be able to take the square root of negative 4. That negative 1 comes out as I, leaving us with the square root of 4, and the square root of 4 is 2. If it doesn't simplify nicely, it's nice to take that negative out as I. Let the yellow calculator do it. The 30xs will simplify radicals for us into simplest radical form. Lastly is x by itself. So what do we need to do? We need to add 2. Since we have minus 2, we need to do the opposite operation, which is add 2, which gives us 2 plus or minus 2i. 2 plus or minus 2i. Because we put in front of the plus or minus, because whenever we add or subtract a number to both sides, we're going to put it in front. If we'd minus 2 from both sides, it would just been negative 2 plus or minus 2i. Now again, just like before, we can say we're done as long as 2 and 2i are not like terms. Are 2 and 2i like terms? No, because I is our square root of negative 1. Since the 2 does not have it, this is as simplified as it gets, 2 plus or minus 2i. So we really do have two answers here, 2 plus 2i and 2 minus 2i are the two answers we have, but this is as far as it goes. Because 2 and 2i are not like terms, we can't add them, we can't subtract. So you're asking how we got from negative 4 squared to negative 4 to 2i. Because really, going from here to here, what we're doing is we have really square root of negative 1 times 4, which according to the properties of radicals I can say is the same as the square root of 1, negative 1 times the square root of 4. Square root of negative 1 by definition is I. Square root of 4 is 2. So then we multiply them back together. And instead of writing it out each time, we've kind of done this little shortcut of saying that negative 1 is going to come out as I, comes out as I, and now we're really just looking at what is that square root of the number. Square root of 4 is 2. If whatever it is, even square root of 6, that's just square root of 6. So it's I square root of 6. So simplify however we need to from there. Now taking the I out works nice with the 30xs. Because our 30xs, that yellow calculator can't take the square root of negative 4. It can't take the square root of a negative number. However, we know I is that negative comes out as I. So even though this here can't take the square root of negative 4, I know that that negative is I. Then I tell it just take the square root of 4, which is 2. So it's going to be 2I. We put the I back in. You're welcome. Let's look at the next one. X squared plus 8x minus 5 equals 0. We can go through these steps here. We don't have x squared. We don't have variables on both sides of the equation. If we do, we do need to get them together before we can really start this process. The only ones we really don't necessarily have to have together are the constant terms, our terms without a variable. So if we look at this here, is the number in front of x squared 1? Yes. If it is, we just move on. We move on to step 2. We want to get the variable on one side, the variables on one side, and our constant terms on the other, our numbers without variables on the other side. And to do that, we're going to add 5 to both sides. And that'll tell us that we have x squared plus 8x plus blank is equal to 5 plus blank. So we move the constant terms to the other side, variables on one side, constant terms on the other, and we're going to leave 2 spaces. And we're doing this so that we can find this value of c that's going to make that x squared plus 8x be a perfect square trinomial so that we can factor it to a single set of parentheses being squared. And as we look at this here, x squared plus 8x, what is the value of b? It is 8, and it would be positive 8. So we have 8 over 2 squared. Well, we'll do the division first. 8 divided by 2 is 4. And then 4 squared is 16. And now we're going to factor. Now it seems like, why do we worry about just finding the square term? Why don't we just find the number inside the parentheses, square it, and go on? But we're having to add it back in. We're having to add it to both sides because we're trying to make it to a perfect square trinomial. And the perfect square trinomial is x squared plus 8x plus 16. I'm adding 16 to the left-hand side. Since I add something to one side, we have to do it together. We have to keep it balanced. And the number inside the parentheses before we squared it to find c was positive 4, telling us that the factor is going to be x plus 4 squared. And this here is equal to what? 21. So we have it factored. Now we just need to solve. So we're going to square root both sides. And on the left-hand side, the square root and square will cancel. So we have x plus 4 is equal to plus or minus, because again, every time we take the square root of both sides, we have to put the plus or minus. Now at this point here, we're going to simplify the square root of 21. So if we take the graphing calculator, take second square root 21, we do indeed get 4.582575695. And what that tells us is that 21 is not a perfect square. There's not a number times itself that gives us 21. And we want to leave it in simplest radical form, if possible. 30xs tells us there is no perfect square factors for 21, because the only factors of 21 are 1 and 21 or 3 and 7. So it doesn't simplify, telling us that the square root of 21 in simplest radical form is the square root of 21. It doesn't simplify. Now, just like with the last so many, x is not by itself. We have to minus 4 from both sides, telling us x is equal to negative 4 plus or minus the square root of 21. Now, negative 4 and the square root of 21 are not like terms. We could add them, but for us to be able to add or subtract these, we do have to convert the square root of 21 into a decimal, and it would be approximate because square root of 21 is an irrational number. It has a non-repeating, non-terminating decimal point, so we would just approximate. So really the best answer for this here is negative 4 plus or minus the square root of 21. That is the exact answer. The decimal version is just an approximation. Questions on this here? Questions on what we've done so far? It feels like this should be a lot more than it is, but when we follow these 4 steps and keep them in this order, these work quite nicely. So let's look at this next one here. We have 3x squared plus 12x plus 15. Now this is kind of nice because variables, everything's on one side. It does work a little better when it is equal to 0. First step is a equal to 1. If not, make it so. Yes. Yes. Because we're going to take whatever that first number is and divide every term by that number. So since the number for a is 3, it means every term, the x squared term, the x, the constant term, what it's equal to all has to be divided by 3. Now 3x squared divided by 3 is going to be x squared plus 12x divided by 3 is 4x. 15 divided by 3 is plus 5 is equal to 0. Now with that 2, a has to be positive. We're not going to be dealing with negative x squared, because that would also be something we would have to fix if it did occur. So step 1, is a equal to 1? If not, make it so. Is a now 1? The number in front of x squared is now 1. So now we can move on to step 2 like we've been doing. Step 2, get the variable one on one side and the constant terms on the other. So we will subtract 5 from both sides, telling us that we have x squared plus 4x plus, we got the constant terms on one side, and we're leaving 2 spaces. We're leaving space to be able to plug our value of c in. That's going to make this a perfect square trinomial. And for this here, we need to know the value of b, and the value of b is 4, specifically positive 4. Telling us to find our value of c, we plug 4 in, giving us 4 over 2 squared. 4 divided by 2 is 2, and 2 squared is 4. So we're going to add 4 to both sides, because adding 4 to the right-hand side will give us this perfect square trinomial. Our set of parentheses squared with x, 2 plus 2, positive 2, so plus 2. And on the right-hand side, we have negative 5 plus 4, which is negative 1. Questions on this here before we start or solving? We already factored. We need 2. Square root both sides. Left hand's nice. Square root and square would cancel, giving us x plus 2 is equal to plus or minus. Now on the right hand side we have what? The square root of -1, yes? What is the square root of -1? It's I. It's just by definition I. This sometimes can be tricky because we feel like it should be something more than just I, but it is. The negative comes out as I. Square root of 1 is just 1, so we have 1I or just I, because I by definition is the square root of -1. Questions on this here? Is x by itself? Well, no, so we need to do what? Subtract 2 from both sides, telling us x is equal to -2 plus or minus I. -2 and I are not like terms, so that's our answer. Yes. Would we say that having a number in front of x squared made these problems a lot harder? No, we just divide by that number. The steps are still the same. Everything is still the same. It's just we had to divide by that number first. So when we look at this next one here, -3x squared minus 18x minus 6. The number in front of x squared, is it 1? Well, no, it's what? -3. So we need to divide this entire equation by what? -3. We're going to divide the entire equation by -3 because we want the number in front of x squared to be 1, specifically positive 1 for this here. Yep. And if we do this division, -3x squared divided by -3 is x squared. -18 divided by -3. Well, the negative and negative make a positive. 18 divided by 3 is 6. We still have our x. -6 divided by -3 would be positive 2. Questions on this here? Questions on anything we've done so far? Now, it feels like we have 2 different equations after we divided by -3, yes? And if we look at the graph, y equals -3x squared minus 18x minus 6. If we graph it, we get this here. Now we can see both solutions are negative, and they don't look like they're nice numbers. They're not crossing at these nice integers. But we divided by -3, telling us that we're now solving x squared plus 6x plus 2 graph. Pretty much every point on the -3x squared minus 18x minus 6 is different than the x squared plus 6x plus 2, yes? There's only 2 spots where it's not. And that's where it crosses the x-axis, yes? They're both still crossing at that same spot on the x-axis, which means those 2 points are still the same, yes? And when we solve it, we're trying to find the values of x that will make the function be 0. We want to find the points where it crosses the x-axis. So even though dividing by -3 changed every other point but where it crosses the x-axis, that's fine, because that's what we're trying to find. Now at this point here, we can subtract 2 from both sides. Telling us that we have x squared plus 6x plus blank is equal to -2 plus blank. So our second step is to get our variables on one side, constant terms on the other. So we subtract 2 from both sides. The value b in our case is positive 6. So we can plug it into our b over 2 squared, giving us 6 divided by 2 squared. And 6 divided by 2 is 3. And then we can square it, giving us 9. So 6 divided by 2 is indeed 3. 3 squared is 9. And we'll take that value of 9 and add it to both sides. Now we just need to factor and solve. So we need to factor x squared plus 6x plus 9. Well, the number that's going to go inside that parentheses is going to be positive 3. And negative 2 plus 9 will be 7. And just like before, we're going to take the square root of both sides. Square root and square are going to cancel, telling us x plus 3 is equal to plus or minus. Now the square root of 7 is going to be, well, the square root of 7. 7 is a prime number we won't have reduced without turning it into a decimal. Last but not least, we will subtract 3 from both sides. Telling us x is equal to negative 3 plus or minus the square root of 7. Questions on this here? Questions on anything we've done so far? Okay. I feel like for the most part we feel comfortable with these here, yes? So I think this was the last one. Okay. What I want you to do is mark it out and put this one in instead. Because completing the square works well for any and all. It works well for every single one. And the nice thing with it is it doesn't have a whole lot of, if it's this case, do this, if it's this case, do that. Different option is the same case, no matter what the numbers, no matter how it looks. However, it does get a little clunky when the numbers start looking a little weird. Because if we look at this one here, 2x squared minus 5x plus 67 equals 0. Is a equal to 1? If not, make it so. So we would need to divide everything by 2. Okay. 2x squared divided by 2 is x squared. Minus, because we're not dividing by a negative, so the signs will stay the same. 5 divided by 2, it doesn't divide evenly, does it? So we'll simplify it as far as we can, and that's just going to be 5/2, which is fine. 67 divided by 2, does that divide nicely? No. And it doesn't simplify any farther than that, so it's just 67 over 2. Now, if they did reduce, if there was some like term that could simplify, we'd simplify it as far as we can. It's going to be nicer, it's going to be better to leave these as fractions than to try to deal with these as decimals. And really for this first step, decimals or fractions doesn't make a difference. Our next step is we need to get the constant terms on one side, variables on the other. So subtracting 67/2 from both sides and leaving 2 spaces, again, it's not making a huge difference. from decimals or fractions. But our step 3 is to find the value of c. And c is equal to b over 2 squared. And for us here, our value of b is -5/2. So this is really the first big part. We're having it as a decimal over or as a fraction over a decimal is a little bit nicer. Because if we had it as a decimal, we would be saying that we have -2.2 or -2.5 divided by 2. We have decimals and fractions, they don't get along. But you might also be saying, well, we have -5/2 over 2. Well, the calculator will tell us easily what that is. -5/2 divided by 2 is -5/4. So we have -5/4 squared. Now to square it, we can grab the calculator and say -5 over 4 squared. Make sure you put parentheses around it, because if we don't, it'll tell us that it's -25/16 instead of positive 25/16. Our value of c that we plug back in will always be positive. The value of c that we plug back in will always be positive. Now at this point here, we need to factor. The number inside the parentheses before we squared it was our -5/4. So x squared minus 5/2 x plus 25/16 is x minus 5/4 squared. Equals, well, -67 over 2 plus 25/16 is -511 over 16. So again, it looks like it's going to be nicer to have just left it as a decimal. But again, we're going to have to take the square root. We're not done yet. So we're going to square root both sides. And on the left-hand side, the square root and square will cancel, telling us x minus 5/4 is equal to plus or minus. Now to simplify this here, we would split it up. We're going to take the square root of -511 over the square root of 16. Now, to do this, we know that that negative on top is going to have to come out as what? I. And we can take the remaining part and put it into the calculator. So it will tell us that the square root of 511 over the square root of 16 as well the square root of 511 over 4, and with the negative it comes out as I. Last but not least, we're going to add 5/4 to both sides, telling us x is equal to 5/4 plus or minus the square root of 511 over 4i. So the fact that b and c were not divisible by the number in front of x squared did make it a few more steps, but not that much more complicated. We will finish this up tomorrow.